Welcome back. This video is to help you with your first test in the section Math 1414. So we already took a test for 0314, but this is actually for the college algebra part. All right, so I'm going to go through each problem. You'll have a problem similar. It'll just look different, but it'll be very similar. It'll just have different numbers. All right, so just a reminder that the domain are our x values, and we can go from left to right. And so I'm just going to scan the x-axis, which is right here, to figure out what those values are. And I'm going to start on the far left. So it looks like -4 would be my first value, and then -3 and 2, right? That's at 2. And then 3. There's, 2 ordered pairs at 3, but I only list it one time. All right, so that's my domain. Now the range are our y values, and so we're talking about the y-axis, which I'll highlight in green. This is the y-axis, and we go from bottom to top. All right, so the lowest point of my graph is right here, so that'd be -5, and then it looks like -2 and 1. This ordered pair is at 3, and this ordered pair is at 5. All right, so I just have to figure out which one that matches. All right, so I'm going to take a look at my answer choices here, and let's see, -5, -2, and 3, 5. Oh wait, that would be the range. Domain, -4, -3, 2, 3. Okay, you don't have to list it twice. So it looks like it's going to be this one, because here they list the number 3 twice, and so we don't want to pick that one. All right, so I'll probably be taking that answer choice off though, because I think that they're just trying to trick you on purpose, and I don't really like when they do that. I just think that's a little ridiculous. All right, so let's take a look at number 2. So number 2 is asking for you to determine if that is a function or not. And if you remember from your homework, the rule is basically that the x's cannot repeat for it to be a function. So what I can do is I want to this is a mapping, so I kind of want to really look at this closely, and I might even write it as ordered pairs. So this would be A, comma, and it's going to 8, and then also A, comma, 3. So you can see that this is my x values, right? So A8 and then A3, and then I have B, -9, B, -4, and B, -10. All right, so what you can see here is that my x values are repeating for both A and B, which is a problem. Okay, so this is definitely not a function. It would be a function if it was just A, comma, 5, B, comma, 3, C, comma, 8. All right, we cannot have the x part repeating. All right, so let's move on. So for number 3, we are now looking at a graph, and we're going to determine if it's a function or not. And graphically, we can actually do what we call the vertical line test. And that's where we take a vertical line across, and we just want to make sure it's only crossing in one spot. Okay, so that would show that the x's do not repeat. All right, so yes, this passes the vertical line test. An example of a no would be if I had a graph that looked like this, and I tried to do a vertical line, and it's crossing in more than one spot. Okay, number 4. Evaluate the function for the indicated value and then simplify. Okay, so this is just our function notation where we're going to be plugging in our value for x. And so f at -6 is when I'm going to take -6, I'm going to plug it in for x. I'm going to wrap it in parentheses so I don't make a mistake. Remember, you can use your calculator. So it would look like this. I would just type that into my calculator with parentheses and all, or I can work it out by hand. But either way, I end up with 48. All right, so for number 4, you should get 48. All right, number 5. says find f at t where it's equal to t squared plus 8t. Find f at t minus 8. Okay, so this one's a little more challenging because we're going to have to take t minus 8 and we're going to have to plug it in for t. All right, so let me show you what that would look like. I would have f at t minus 8 is equal to, and all I'm doing is replacing my t's with t minus 8. So I'll do this in red. So I'm going to have t minus 8 squared plus 8 times t minus 8, right? And so from here, I need to work this out. I'll distribute here, but over here I've got to expand it. So it's going to be t minus 8 times t minus 8. And then I could do distributive property or make a box, and I would get t squared minus 8t minus 8t plus 64, which would be t squared minus 16t plus 64. Okay, so all I've done is I've worked this out, and I got this, and so now I'm going to drop down this part, and I can go ahead and distribute. So that would be positive 8t minus 64, right? I just multiplied that. So I'm going to drop this all the way down, and then I'm going to combine my like terms. So this just got dropped. And so when I combine my like terms, I have a negative 16t plus an 8t, and then I have positive 64 minus 64. So the cool thing is the 64s get, they get canceled out. But when I combine my t's, I end up with t squared minus 8t. And that is letter D. Alrighty, let's take a look at number 6. Number 6 says determine the domain and range of the function. I'm going to kind of scoot this over a little bit. Okay, so, and I have to say that when the line goes off of the window, you can basically assume that it has arrows, right? Because we don't see like a solid dot anywhere or ordered pair anywhere. So we're going to assume that it has arrows. All right, so once again, our domain is going from left to right, but this time we have a continuous function. That is, we don't have ordered pairs all over the screen, but we still want to go from left to right. So when I look at this graph and I think about the x-axis, which goes on forever, right? Then when I think about the fact that this has an arrow, that's going all the way to the left. So it'll eventually get to -6, -1,000, -1,000,000, basically negative infinity. So this is going off the screen, and it's actually going to be starting at negative infinity. And infinities always get parentheses. And then as far as how far right does my graph go? Well, it's pointing to the right. It's going off the screen. Eventually it gets to 100, eventually it gets to 2,000, eventually it gets to infinity. All right, so my domain is negative infinity to positive infinity, which you can see kind of narrows my choices here, right? So it can't be those two. Now for my range, we're talking about bottom to top. And so I'm going to scan the lowest point of my graph, which actually is right here. Okay, so that's going to be at 1. And the reason why I put a bracket on the 1 is because there is an ordered pair here, right? These are all made up of ordered pairs. This line's made up of an infinite amount of ordered pairs. And so it starts at 1. There's no open circle on the graph. Like I would put a parentheses if there was a giant hole in the graph, but there isn't. So I start at 1, and then how high up does my graph go? Well, it's definitely past 4 and it's past 5. It's going to go on forever, all the way to 100, all the way to 1,000, all the way to infinity. So it goes all the way to infinity. So I'll be looking for a range that is from 1 to infinity. And that is right here, right? So letter C for number 6. Okay. All right, let's keep going. Okay, so number 7 is very similar. We're doing the domain and the range again. But this time you can see, I hope, that over here, we're not going to have an arrow on the left side, right? Because that's just an ordered pair, it stops. But on this side, we will assume there's an arrow there. Okay, so I just want to point that out in our picture. So now we're going to go once again from left to right. So from left to right is how we describe our domain. We talk about the x values. So the farthest left for us will be -3, right? That's like where our graph starts. And I get to put a bracket because it is a closed circle, all right? And then how far right does my graph go? Well, eventually this arrow goes all the way that way, which means eventually it does get to infinity. And so we'll put an infinity there. All right, and that's always going to at least eliminate two or one of your choices. Actually two, because this has a parentheses bracket, which is weird. Ooh, I think I'm done. Oh well, I'm still going to go through the range for you. So then for my range, I'm going to go from bottom to top. So the range is from the bottom of my graph to the top of my graph. So I'll do this in yellow. So here's my y-axis. Where is the bottom of my graph? I'll do this in green. Well, this is the low, actually, no, sorry. This is the lowest ordered pair on my graph, right? It's going all the way down. So because it's going to eventually go all the way down, our lowest value is actually -infinity. Now our highest value is going to be -2, as I can see that it reaches -2, and that's going to get a bracket because there are ordered pairs here that make up this continuous line, right? It's not like there's an open circle. It would be if it looked like this, if there was like a hole in the graph, then you could say that that would be a parentheses, right? But these are all ordered pairs, so that's why we get a bracket. All right, so that is letter C. Whoops, sorry, let me highlight that for you, or circle it. All right, now we're going to talk about some transformations. All right, so we're going to use transformations to graph the given function. So what's cool about these is I can tell by this expression that the parent function is the square root of x. And in my notes, hopefully I know that the square root of x usually looks like this, right? Where I've got an ordered pair at 0, 0. Okay, that's going to help me because what's happened is it's been transformed, right? So if you remember from your transformations, if it's inside the radical, that's like parentheses, that's going to move it to the right 2. And then the positive one here actually moves the graph up 1. So I'm going to take what would be at 0, 0, and I'm going to move it to the right 2 and up 1. So this one would be no, because it's actually to the left 2, so that would be out. This is to the right 1 and up 2, right? Because I can see it would start here, but it's gone to the right 1 and it went up 2, so it's not this one. This one has been moved to the right 2 and up 1, and that's what I was trying to find. All right, so I'm using this equation to describe the transformations, and I'm just matching the graph. All right, so let's try number 9. So for number 9, I'm sorry, it looks like the instructions are on the other slide, but I can tell you what they were. It says to graph the transformation f at -x. And so if you remember, if there's a negative inside next to the x, that's going to reflect the y-axis. And so if it reflects the y-axis, basically my x values will become opposite. And so here is the y-axis, right? So what we're imagining is we're going to take this graph, we're going to reflect it over this blue line, and it's going to end up on this side, right? If I took that and I reflected it across, you can imagine if I folded a paper and then I flipped it over. So I need to have something that is basically going to be like, kind of like that, right? And so, actually there's more curves there, hold on. It would be like oscillating a little more. Okay, so that one would be here, and if you're having trouble discerning between C and D, we would pick this one. Oops, sorry. We would want to pick D, because if you look closely, you can see that this little part right here and this little part right here, when I flip it over, it's going to be here and here, right? So it's not going to be up. So they're kind of trying to trick you on letter C. All right, let's keep going. Let's try number 10. So number 10, we're using transformations once again to graph this. And so we have this transformed equation. Let me write this a little bigger. Oops, my gosh. Okay, So my parent function, it always helps to identify the parent function. So the parent function I can tell is x squared, right? So it was x squared and all these things happened to it, right? That's why they call it the parent function. All right, so what has happened to it? Well, we have a negative in front. So that means it will reflect the x-axis. Basically, it's going to flip over like this, right? Because usually x squared, just a reminder, the parent function x squared is just a parabola that looks like this, right? So if we put a negative in front, it's going to reflect the x-axis, right? And then this x plus 2 is going to go to the left 2, right? It's in parentheses. If it's positive, it goes left. If it's negative, it goes right. And then this plus 3, we'll just simply move it up 3. Okay, so we're trying to find a graph where it usually starts at 0, 0, but instead we need to go to the left 2, we need to go up 3. All right, so I start here, I go to the left 2, 1, 2, but I didn't go up. Here I would go to the right, so it can't be that one. Here I would go to the right, so it can't be that one. This one, I go to the left 2, 1, 2, I go up 3, 1, 2, 3. Okay, that checks out, and it's also flipped over, right? So it's definitely D. All right, let's try number 11. All right, so for this one, we're going to be describing the transformations to this function. And so it's very similar. We're not graphing it. We're just going to describe it. So g of x is equal to 1/4 x plus 3.5 squared minus 2.1. Okay, so my parent function I can tell is just x squared. And if you remember the 1/4, what that does to the graph is we say that it's a vertical shrink by 1/4. If it was greater than 1, we would call it a stretch. So it's a vertical shrink by 1/4. The x plus 3.5 simply moves the graph to the left, 3.5. And then the minus 2.1 moves the graph down 2.1. Okay, so I'm just looking for that description in my answer choices, all right? So I read each one, and eventually I realize that it's A. Alrighty. Number 12, identify the vertex and determine the minimum or maximum value of the function. All right, so this is already in vertex form, which is great. So if you remember that we can actually use transformations, or we can just, if we have that memorized, we can use the memorization technique. But basically, this would go to the right 3 and up 2, or you change the sign, keep the sign. So the vertex is at 3, 2, which eliminates some of these choices. And then, since it's a positive quadratic, it's going to have this general shape of a U. It's called a parabola, which means it does have a minimum value and not a maximum value. And so that's why I would choose the minimum over the maximum. All right, so that one shouldn't take you too long. It's just knowing what the vertex means. Okay, so for number 13, we have x squared plus 6x minus 7. We're going to find the vertex. There's 2 ways to do this. You can complete the square, or you can use the vertex formula. I'm going to actually use negative b over 2a and f at negative b over 2a, because we're going to use that kind of often on our other problems, and so it's good to practice. And just keep in mind that a would be equal to 1, b would be equal to 6, and c is negative 7, but we don't really use that part. So, all right, so I'm going to put negative b. So for negative b over 2a, where b is 6, I'm going to have negative 6 over 2 times 1, which is negative 6 over 2, which is negative 3. All right, so these choices are out. And then that's just half of my vertex, right? That's just this piece. To find the other part of my vertex, I'm actually going to take negative 3 and plug it in for x. All right, so that will give me the f at negative 3. So f at negative 3, so I take what I got for x and I plug it in to the original. So I do negative 3 squared plus 6 times negative 3 minus 7. Okay, and when I work that out, and you can totally use your calculator if you'd like, so you don't make a mistake, I end up with negative 16. All right, so my vertex is at negative 3, negative 16. We're actually going to do that for the next 2 problems as well, so it's good to practice that formula. All right, so remember, this is the formula that you can use to help you to find the vertex. Okay, so on number 14, we're going to find the vertex of the parabola by applying the vertex formula. We'll do the same thing. So we're going to do A is 3, B is negative 30. So I'm going to do negative B over 2A. So negative 30 over 2 times A. And that will give me positive 30 over 6, which is 5. All right, so 5 is the first part, so I can cross these out that don't have a 5. And then I'm going to do F at 5. So F at 5, so once I find the x coordinate, I'm just plugging it in to find the y value of my vertex. All right, so that's going to be 3. And then anywhere I see an x in the original, I'm going to be plugging in a 5. And then this part, I would totally use my calculator for. I don't expect you to work that all out by hand because it's easy to make a little careless mistake. So when I do all of that, oops, sorry, I end up with negative 149. All right, cool. So now we have a word problem. It says, a fireworks mortar is launched straight upward from a pool deck 8 meters off the ground at an initial velocity of 59 meters per second. The height of the mortar can be modeled by h at t equals negative 4.9 t squared plus 59t plus 8, where h at t is the height in meters and t is the time in seconds after launch. What is the maximum height? Cool. Okay, so typically this is what a quadratic would look like that's negative, and we're trying to figure out the maximum height, which will be, so this is time and this is height. So we're really looking for the y coordinates of our vertex. So we must find the y coordinate of our vertex. And I also want to point out that it's great that they tell us all these things. That's cool. But really, we're just using this equation. All right. So let me rewrite that for you. And so what we're going to do is similar to what we just did on the last two problems. We're going to find the vertex. And so we're going to use negative b over 2a, f at whatever we get when we do negative b over 2a. And the reason why I have to find that in this case is because it's only asking me really for this. But I need to find the x coordinate before I do that, right? All right, so negative b over 2a, where a is negative 4.9 and b is 59. And remember, I just get those numbers from here. Okay, and so I'm going to have negative 59 over 2 times negative 4.9. All right, so when I calculate that carefully in my calculator, I get approximately 6.0204. Okay, I'm going to go kind of farther. Now, I have to take this and plug it back in for t to find the height. Okay, so this is the x coordinate of the vertex, but we need the y coordinate because it's asking for the height. So now I'm going to do f at 6.0204, and that's just going into the original, which I'll do in red. So it's going to be negative 4.9 times 6.0204 squared, and then plus 59 times 6.0204 plus 8. All right, so I'm just plugging it into this equation. And I will calculate that, of course, with a calculator, especially with all those decimals, okay? So let me do that, and I'll tell you what I get. All right, so when I worked that out in my calculator, I ended up with 185.6020, blah, blah, blah. And this is talking about meters, and it is asking us to round to the nearest meter. So this would round to approximately 186 meters, which there is no answer choice that's even close to that. So hopefully you don't get too worked up on the rounding. All right, we just have 2 more. This test is not as long as the other test because it covers less material. All right, so we're going to use interval notation to figure out when it's increasing. Okay, so when we do interval notation, remember you always go from left to right, and you use your x values to describe. All right, so in this case, we're asked to find when is it increasing. So I want you to think about, if you're on the graph from left to right, if you're a star, at what point would you be increasing, or where would you be increasing at? Well, I would be increasing from here to here, right? And then in the rest of the time, I'd be constant or I'd be decreasing. So really, we're trying to describe from here to here. We're going to use our x values, right? Our x axis to describe that. Okay, so that little sliver here is from -4 to -2. And with intervals of increasing and decreasing, we don't use brackets ever. So you can see that's not even a choice. Okay, cool. So one more, it says use interval notation to write the intervals over which it's increasing, decreasing, or constant. Okay, so once again, we're going to go from left to right, imagining you're on the graph. All right, so we're going to do it says to start with increasing. So we're going to do increasing, decreasing, and constant. All right, so if I imagine I'm on the graph right here, and I start at the far left, I would be going down, right? If I'm a star, I'm going down. Okay, so that would be decreasing. So it's decreasing from -5 all the way to -2. Okay, then I get here and I become constant, right? I'm not going up or down. How would I describe that? Well, that would be from here to here, which is -2 to +2. So constant would be -2 to +2. And then I get here and I'm going down again. So that would be from 2 to, and you can assume there's an arrow because it goes off the window, all the way to infinity. It's decreasing all the way down, all right? So I'm going to put a U here, and it would be from 2 to infinity. It's not increasing at all. It's never increasing. If you were on that graph from left to right, you would never increase. Okay, so that one, if I match it up, is going to be letter D. All right, I hope this video helps you, and I hope you do well on your first test for 1414. All right.